Good afternoon, third grade online learners. Today is January 12th, 2021. It is a Tuesday. Welcome to third grade science. We are studying sound waves. And I was telling the class it could be a little bit confusing because in each grade we learn similar things. And it's important that I have the third grade book, which I do. If at home you are doing this with a textbook, you want the book with the parrot on it. Believe me, it's confusing. Every year we learn similar topics, and they just add a few pages, a few more vocabulary words, and things expand from there. But make sure you're looking at waves. And yesterday we talked about a sailboat and how it can go up and down the crest and the trough of the waves. We also talked about wavelengths, the distance between the tops of the waves. And I believe that's where we left off, but in class we read about this girl playing the guitar, who we affectionately call Guitar Girl. Okay, sound waves. Sound is a form of energy that travels in waves. Sound is produced when particles of matter vibrate or move back and forth quickly, such as in this picture. A guitar string vibrates when you pluck it. The string moves back and forth so quickly that it looks like a blur. The movement of the string creates sound waves in the air around it. The sound waves move out in all directions from the vibrating string. You hear the waves as sounds. When a guitar string is plucked, it vibrates. The energy of the vibrations travels through the air as sound waves. On the next page, we continue to see these sound particles moving throughout the air from that original guitar. Question? Yes. A sound wave moves particles of matter back and forth. It's like a spring that is squeezed and then released. As the sound wave travels through matter, particles of matter squeeze together and then spread apart. This happens over and over again as the wave moves away from its source. A crest is where particles of matter are bunched close together. A trough is where particles are spread apart. This happens over and over again as the wave moves from the source. Remember, it's a sound wave. A sound wave travels from its source. The particles that carry the wave do not travel with the wave. The particles move back and forth but stay in the same general location. For this reason, a sound wave can travel only through matter. It cannot travel through empty space. So I mentioned yesterday, if you're in outer space and you yell or make a loud noise, nobody's going to hear you. Okay? It needs something to travel through. So in empty space, there's nothing out there, no atmosphere, nothing for it to travel on. Nobody is going to hear you in outer space. The good news is when you're in outer space, you usually have an astronaut suit on, and you can't talk without, they have microphones and different things they can use to communicate. But if it was no mask, they had a problem, there'd be no noise also, and you'd float off into space. Next page, and Claire has a question. Claire, what is your question?
What if you whisper in somebody's ear in space? Would they still hear you?
Oh, if you whispered in their ear in outer space, would they still hear you? I'm not sure about that. I'll look into it and I'll see. I'm not sure that that's ever happened, but in theory, we would have to see, would that work? Yes?
Don't people, like astronauts, don't they just have a rope connected to their spaceship and then they just kind of float up there?
Yep, astronauts are always tethered or tied to the spacecraft somehow. They're not going to just be out there floating around because they might just float away. We'd never see them again. Okay.
I always thought I would be really weird and I just thought it was weird why they're just out there floating.
Yeah.
They're not close to the thing.
Well,
in case the rope breaks.
Well, I can tell you one thing, guys. When astronauts go into outer space, they don't stay out there very long. And they are tied to the spaceship, or else they would just float away.
I thought they stay out there for at least a year.
No, they can go into the... Yeah, they can go to the space station, but they're not going to just float around into outer space. Okay, there's a big difference between the tweet of a songbird and the growl of a lion. Vibrating matter produces both sounds, but one sound is much higher than the other. How high or low a sound is called pitch. Pitch depends on the frequency of sound waves. High-pitched sounds have high-frequency sound waves. Low-pitched sounds have low-frequency sound waves. Small objects vibrate more quickly and make higher-pitched sounds. Large objects vibrate more slowly and make low-pitched sounds. So for that, we have the girl showing you different bottles she's blowing into, and a jackhammer. Before I go to the next page, third grade, I wanted to mention at 3 o'clock today, I will be on for a live Google Meet for online learners at home from 3 o'clock to 3:15. And that's for grades 3, 4, and 5. And all you have to do is go on Google Classroom, go on the stream section, and click on the link. And this is if you just want to talk to me for a little bit, ask me a question, or just talk to me live in person rather than these recorded videos. I call the name of this program or option Tuesdays at 3. Tuesdays at 3 with Mr. Monzo will be for 15 minutes anytime that we have online learners at home and kids at school. If everybody's at home, then I'm not on at 3. But if you're at home and everybody's here, Tuesdays at 3 is your chance to interact with me. Okay, doing a quick time check, and let's look at this page, loud and soft sounds. We have a mouse and a guy working a jackhammer. How loud or soft a sound is seems is called volume. Volume depends on the size of the crests and the troughs of the sound waves. A sound with volume, such as a siren, has waves with high crests and deep troughs. A sound with low volume, such as a whisper, has low crests and shallow troughs. Waves with high crests and deep troughs have more energy than waves with low crests and shallow troughs. You can hear the difference in energy as a difference in volume. A mouse makes high-pitched sounds. A jackhammer produces very loud sounds. High-volume sounds can hurt your ears. Ear protectors reduce the amount of sound that reaches the ears. Last but not least, a very neat topic, dolphins. Sound moves through matter. Most of the time you hear sound waves that travel through the air, which is a gas. Sound waves can also travel through liquids. Dolphins use sound waves to communicate with each other underwater. Sounds can also travel through solids, such as a wooden door. Sound waves travel faster through solids than liquids. They travel faster through liquids than gases. Sound waves can reflect or bounce off of objects. Reflected sound waves are called echoes. You can hear echoes when sound waves bounce off the face of a large building or walls of a gym. Dolphins use sound to communicate. Dolphins can communicate over long distances because sound waves travel a long way through the water. Okay? Will a sound travel fastest through water, air, water, or wood? It's going to travel fastest through wood, ironically. Okay, so that is our lesson for today, third grade online learners. Just let me repeat that if you want to talk to me live and in person, that will be happening in approximately 1/2 hour on Google Classroom, third grade. Click on the stream, then click on the link, and you could talk to me live and in person. You do not have to do this. If you'd rather watch Dr. Phil, go ahead and do that because it's on at the same time. If you want to talk to me, click on that link and let's talk for a little bit. I don't have much time, but I have a little bit of time to see if you have questions or you just want to see how I'm doing and how you're doing. Okay, online learners, we'll see you later. Bye-bye.